In these two examples, we are going to be finding some trig values, might be a little bit more challenging, just kind of given some of the information. But our kind of main goal is we're trying to find sine, cosine, and tangent, and I always find a visual very, very helpful. So I want to figure out, I'm going to draw a picture, draw a triangle, and I just got to figure out what quadrant we're going to be in. So given the fact that cotangent is 1/5, and sine is less than 0, so sine's a negative. I can use this idea, a smart trig class, to kind of help this out. So tangent, which basically, since this is cotangent, which really means we have tangent is 5/1, or 5. So tangent is positive and sine is negative. So tangent being positive narrows us down to these two quadrants, and sine being negative narrows us down to this. So we're going to draw a picture. So we just have some sort of a right triangle. Tangent is opposite over adjacent. So there's our theta, opposite over adjacent. Now, because of the direction that we're going, that makes that negative and that negative because we're going left and down. And a negative over a negative would in fact make our positive. So we need the hypotenuse. So to figure out the hypotenuse, we are looking to do Pythagorean theorem. So we have a -1 squared plus a -5 squared equals the hypotenuse. I don't know, we'll call it c squared. So that's 1 plus 25 equals c squared, so that's 26 that we are going to square root. So our hypotenuse is the square root of 26. Okay, so once we have that, we literally have everything we need. We're going to have to do some cleanup stuff though, because our hypotenuse is a square root, so sines and cosines we're going to have to clean up. So we'll do sine of theta equals opposite over hypotenuse, so -5 over square root of 26. But we're going to need to rationalize the denominator. So we'll multiply by square root of 26. So that gives us a -5 square root 26 over 26. So there's sine. Cosine is going to be adjacent over hypotenuse. So that's going to give us a -1 over square root of 26. And then we'll rationalize that denominator as well. And that gets us negative square root of 26 over 26. And then the good news on tangent is we were pretty much given it. So we already have tangent to be 5. Okay, so that's first example. Second example is similar. But this time you're given that sine of negative theta equals something. Key is knowing that there's a property that has sine of negative theta is equivalent to negative sine of theta. So sine of theta is this root 33 over 6. Just means we need to tack negative onto it. So that's what our sine of positive theta is. So same thing, we're going to look to figure out where we're at. A smart trig class. And cotangent, so tangent is negative, leaves us into these two quadrants. And then sine is also negative, which means we're going to draw our picture in the fourth quadrant. So fourth quadrant, sine is opposite over hypotenuse. Our hypotenuse is 6, and our opposite is negative root 33. Pythagorean theorem again to figure this out. So we have negative root 33 squared plus, this will be our x value, x squared equals 6 squared. So that's actually just positive 33 plus x squared equals 36. And if we subtract that over, we'll get x squared equal to 3 square root x equals the square root of 3. And because of the direction, it should remain positive. So square root of 3, and we now have everything. So sine, we already know, sine of theta equals negative root 33 over 6. Cosine of theta equals, here's our theta. So sine was opposite over hypotenuse, cosine is adjacent over hypotenuse, root 3 over 6. And it should stay positive, and then tangent is going to be opposite over adjacent, so negative root 33 over root 3. And then this one's going to take a little bit of work because we're going to multiply this to rationalize the denominator, and that's going to get us a negative root 99, which has a perfect square in it, and this becomes square root of 9, which is 3. But this has a perfect square of 9 in it, so I can take a 9 out, which would leave us with an 11. And so if I simplify that, I'll get a negative 3 root 11 over 3. 3's cancel, so it's just a negative root 11. Okay, and that was just a little bit harder, really mainly just because we had square roots kind of throughout the whole problem, and then the fact that we have a trig identity here of sine of a negative theta is equivalent to a negative sine of a positive theta. And that's it. Thanks.